So this video is going to focus on adding, subtracting, and multiplying functions. Now, what we've been doing in class has been adding and subtracting polynomials, and what we're going to do in class Wednesday and Thursday is adding in multiplying polynomials. So the only big difference here is that this is going to be applying to functions, okay? But there's not much of a difference of what we've already been doing. So I want you to look at the function notation. So you should have seen things like this before, okay? Function notation is where we have a notation specifically like f of x, g of x, h of x, and these are similar to thinking about a function on an xy axis. Okay, so you know that functions have graphs. So each of these could technically be graphed on a graph, but we're not going to be worrying about that. We're going to be worrying about how to add, subtract, and multiply these functions. So I want you to notice that each of these functions is either a binomial or a polynomial. And so if we are adding, subtracting, and multiplying functions, then we are also adding, subtracting, and multiplying polynomials, which is what we have already learned how to do. So again, this is the same thing that we've been doing, all right? It's just going to look different. It's going to be presented different, but the methods are still the same. So I want to give you an example. So here you are given two functions. You're given that f of x is equal to 2x squared minus 3. You're given that g of x is equal to negative 4x squared plus 3x minus 7, and you are asked to find f of x minus g of x. Now what this means is they want you to perform the operation of subtraction on these two functions. Okay, so we know that the f of x function is 2x squared minus 3, and we know that the g of x function is 4x squared plus 3x minus 7, and we are subtracting those functions. Now this should look exactly like what we have been doing in class. So the only thing that we had to do in addition was using the function notation instead. Once we're here, you know how to do this. So I'm going to do like I did in class and line them up in my columns. So 2x squared minus 3, and I'm going to line up my like terms, but I'm going to change all of the signs so that I can make this addition. So I'm going to change my positive 4x squared to a negative. The positive 3x squared I'm going to change to a negative, and my negative 7 I'm going to change to a positive. So now I'm adding. So I just have to line these up. So underneath the 2x squared, I'm going to put a negative 4x squared. The negative 3x doesn't have anything to go under, so I'm going to stick it out to the side. And the plus 7 lines up under the negative 3. Now I just combine those like terms, and I get negative 2x squared plus 4. Put a 0 up there to hold my place, minus 3x. Put it into standard form, and my final answer is negative 2x squared minus 3x plus 4. Alright, now let's look at one that has multiplication. So here you have given f of x equals 2x, g of x equals 3x plus 2, and it says find f of x times g of x. So this is a little bit different. Now if you're watching this after class, then we've already talked about this a little bit. If you're watching it before class, you need to pay close attention. So when we're multiplying functions, we are putting them into parentheses next to each other. So f of x is 2x, g of x is 3x plus 2. I can put this 2x into parentheses, but because it's only one term instead of an expression, I don't really have to, okay? So in order to multiply this, you should already know how to do this for the most part. We got to use the distributive property. So I have to distribute my term to both terms in the parentheses. So when we're multiplying 2x times 3x, we multiply the numbers first. 2 times 3 gives me 6. X times x gives me x squared. Okay, and we'll change colors. Now, when I multiply 2x times 2, I multiply the numbers to get positive 4, so plus 4. And then the x doesn't have anything to multiply times, so it just comes along. So your answer is 6x squared plus 4x. So easy, right? So one more, and this one's a little tougher. So this is another multiplication problem, but this time we've got two binomials multiplying times each other. So we've got f of x times g of x. So that's going to be 3x plus 2. That's an expression, so I put it in parentheses, and it's going to be multiplying times 2x minus 4. All right? Now, the problem here is that you've got two terms multiplying times two terms. So what you have to do is you have to distribute both terms in the first expression to both terms in the second expression. So I'm going to use the arrows to try to help you see this better. So I'm going to distribute this 3x to the 2x and the negative 4. Then I'm going to distribute the 2 to both as well. I have to multiply the 2 times the 2x and the 2 times the negative 4. So I'm going to take this in order from front to the first one. So 3x times 2x would be 6x squared. Then I'm going to do 3x times negative 4. That would be negative 12x. Now, I'm done with this one. I'm done. Now, I have to move over and do the 2. So now I got to multiply the 2 times 2x, gives me plus 4x. Then I multiply the 2 times the negative 4, and that gives me minus 8. Now, I have a polynomial here, and I need to simplify it. I got to get all of my like terms. I want to have just one term per variable, so I've got to combine my two middle terms. I end up with an answer of 6x squared minus 8x minus 8, and that's my final answer. So that is probably the hardest part, is how to multiply these. A lot of people think of it as the extreme distributive property, because you are not distributing just once, you're having to distribute twice.